Good. And today we are going to discuss another problem of the day of leetcode, that is, find the largest area of square inside a rectangle. So first of all, let's read the question and see what it says. There exist n rectangles in a 2D plane with edges parallel to the x and y axis. You are given two 2D integer array, bottom left and top right, where bottom left and top right represent the bottom left and top right coordinates of the ith rectangle respectively. And what we need to find the maximum area of the square that can fit inside the intersecting region of at least two rectangle. Okay, so at least two rectangle, we can have intersecting region of more than two rectangles as well. And we need to find the maximum area of the square which is present in the intersecting region of as many squares that we consider. Like if we have two squares, if we have two rectangles, then we need to find the maximum area, intersecting area of that two squares. If we consider three squares, then we need to find the maximum area of the intersecting region of those three rectangles, and so on and so on. Return 0 if such a square does not exist. Okay. So first of all, let me explain the solution problem in a much better way. That we have been given, let's say, three squares, three rectangles with us. Okay, let's number them A, B, and C. Now I need to find, let's assign this as well, 0, 1, 2, 3, 4, another 0, 1, 2, 3, 4, and 5. Okay, so we have made this grid and we have taken an example to display what the problem says. So in the problem, we have been given the over layout of the rectangles like this, and we need to find the largest square formed by intersecting rectangle. Intersecting rectangles. Okay. So first of all, there is a very important observation when you see this problem to perform the operations ahead. Okay. So let me first explain you the observation that we need to have while solving this problem. Let's say we take an intersection of three rectangles. This is our first rectangle, A. This is our second rectangle, that is B. And this is our third rectangle, that is C. So when we have three rectangles, then we have, let's say we have these three rectangles and we consider the intersection of all these three rectangles. Then in that scenario, the area that is present here is just this one, because this is the only area, let's call it A1, which is present in the intersection, which is present inside A as well as B as well as C. So this area A1 is present in the intersection of all these rectangles, so it is one of the area that we have. Okay, let's go ahead and talk about intersection of two rectangles. Now let us consider that we have the same rectangles again, A, B, and C. Oh, has the position changed? Okay, never mind. Let's reverse and make it again. Okay, this is how it looked like. So we have A here, we have the B rectangle here, and then we have the C rectangle here. Okay, so this is A, this is B, and this is C. Now let's say we consider only the intersection of A, B and C, A of only two rectangles. So it could be the B intersection C, it could be A intersection B, or it could be A intersection C. Okay, now let's consider we have B intersection C first. In that scenario, we have this area which is same as A1. Okay, now let's consider A intersection B. In that scenario, we have this area. Let's like mark it a different pattern. This entire area. Let's call this area A2. Okay. And now let's consider A intersection C. In that scenario, we find the area is this much. And let's call it A3. So what we find is that B intersection C gives us A1, A intersection B is giving us A2, and A intersection C is giving us A3. So it's visibly also conclusive. You can see visibly that A3 and A2 is larger than the A1 which we got from A intersection B intersection C in this step ahead. So we come to an obvious conclusion that when we have two rectangles, let's say A and B, and this is the intersection of these two rectangles, in that scenario, when we consider another rectangle intersection with A and B, that rectangle never increases the intersection area. It will either keep it the same. Let's say if the rectangle is like this, in that case A intersection B intersection C will remain the same, or this rectangle can be something like this. In that scenario, this area would decrease when we consider A intersection B intersection C. So we get a conclusion from this, that is, intersection of two rectangles gives us the maximum area. This is one of the conclusions that we get, that intersection of two rectangles gives us the maximum area. So let us suppose if we add one more rectangle to the already existing intersection of two rectangles, that's only going to either keep the area same or further shrink it. So that's why in this problem, we won't consider intersection of 3, 4 and so on rectangles. We would just consider the intersection of just two rectangles, two rectangles, because only that would give us the maximum area. Taking more than that would either keep the area same of the square or further shrink it. Okay, so now let's focus on the problem again. So we had like two rectangles, right? Three rectangles with us, something like this, and then we had this, and then we had further this. Okay, A, B and C, and now we need to find the maximum area. So what we are going to do in this scenario is, since we have to consider only two rectangles For intersection, we can check for all the pairs of rectangles that we have. We can check for A intersection B, we can check for B intersection C, and we can check for C intersection A, and try to find that, okay, which intersection gives us the maximum area, have a max area variable, and store the maximum area in that. Okay, and store the maximum area in that variable. So how it's going to work out? So let's say if we have uh, again the same example as above. Let's say we have A and B. So if we are going to check for pairs of all the rectangles possible, and try to check that which pair gives us the maximum area. So let's say we have these two rectangles with us, A, B. We will consider two cases in which the two rectangles are intersecting, and in cases where two rectangles are not intersecting and won't have a common area. Okay, so let's say we have these two rectangles, and as we can see, they are intersecting here. Let's name the coordinates. Let's name this A comma B. Let's name this C comma D, E comma F, and G comma H. Okay. Now, if we need to find the maximum, let's say this is the area A1 with us, and we need to find the area of this A1. That, okay, how we are going to find the area of this A1? So for that, what we are going to do is we consider these two coordinates that's given to us. We consider these two coordinates given to us, that is this one and this one. Okay, but in the problem we only have A comma B, C comma D, E comma F, and G comma H. Then how we are able to conclude that what are these coordinates and how we will find the area? So first of all, we know that this C comma D is the topmost point of A, and this G comma A and G comma H is the top right point of B. So now, like, either when we are finding the span of this A1 in the x direction, in that scenario this would involve the x coordinates of C and G. So either it could be C or it could be G if it's intersecting. Okay, so let's consider with now, like, it can be either C or G, but we know that since they're top right, that means that one of them would be ending before the other in the x direction. So in that scenario, what we take the minimum of the top right of B and rectangle A in the x direction. That is, we take the minimum of G comma C in the x direction, and now we have found this coordinate, and now we need to find this coordinate in x direction as well, so we can find the total width of the rectangle. So how we can find that? For finding that, we have the coordinates of these two as well. So let's say we find that we have E comma F and we have C comma D. We have E comma F bottom left, and we have bottom left of B, and we have bottom left of A. Now since one of them would be ahead, since it's an intersecting area, one of these coordinates would be ahead. In that scenario, we will just do max of E comma A. So this would help us to find the minimum, the width of the intersecting area, the same way we can also find the height of the intersecting area. What we can do minimum of in the y direction. What we can do in the y direction, we have H comma D, that is consider for this the top right y of a and b, and minus max of, we can do b and f. So this is going us to give the width and the height. But there is another problem, like width and height can be different and could rather form the rectangle as well. But in the problem, we have been given that we need to find a square. So what we are going to do, let's say we have a rectangle with w and height h. In that scenario, if we have to find a square that fits inside it, then it could be either this one, or if the height is a smaller thing, or if height is a larger thing and width is smaller, then it could be this one, where this is the width and this is the height. So this is width, width, and width, and here is height, height, and height. To find a square inside a rectangle, so what we're going to do, we are going to take the minimum of width and height. Let's store it in a variable called length, and then finally area of square, len into len, is compared and stored, and finally we are able to track the maximum area that is formed by intersection of any two rectangles that we have. Okay, let's say if these two rectangles, take the same two rectangles, and let's say what if it doesn't intersect, they don't have a common area, and this is again a comma b, this is c comma d, this is e comma f, and this is g comma h. So as we saw above, when we were calculating the width or height of such a rectangle, what we were doing, we were taking the minimum of the top right in the x direction of rectangle b as well as rectangle c. So we took minimum of top right of g comma c, because if we cross the minimum of any of these coordinates after that, there is no intersection. And when we were doing maximum of, then we were doing maximum of bottom left of both these rectangle in the x direction, that is maximum of a and e. And we know that, like and why we were doing that, because we know that behind the maximum that is stored, behind that there would be no intersection as well, because there would only be one rectangle going on. So we take maximum of a comma e. In this scenario, in the visualization, we can see that it's going to give us g, but here it's going to give us e. And since e is greater than, sorry, once again I repeat, I'm taking the minimum here, so it would store c here, and it is going to store e here. And since we know that e is greater than c, this width value would come out to be negative, and this would be a sign that, hey, if width or height is negative, in that scenario we need to return 0, because in this scenario, because we cannot form a square when there is no intersection between two rectangles. So if either width is less than 0, or we have height which is less than 0, in that scenario we can simply return zero for that particular let's say intersection of two rectangles, or we would simply come out of a for loop and simply reject that particular intersection. Okay, so now what's the time complexity and the space complexity of a solution? Since we would be considering all pairs since we would consider all the possible pairs of rectangle that could form a square, in that scenario, we would be needing two for loops, So the structure would look like for int I equal to 0, I less than n. Let's say that's the size of the squares that we have been given. And for int j equal to I plus 1, I less than n, and comma j plus plus. And since we'll be using two loops for going across all the possible pairs of rectangles that can be formed, so the time complexity would be on square. And the space complexity, since we're not using an extra space or vector, so the space complexity would be big O of 1. Okay, so this was the solution of the problem. So now let us see the code. Okay. So now let's analyze the code of the solution. So basically what we do, we have like n, which is the size of the vector that we have been given. We take another variable, largest area, which is going to store the maximum square area that we encounter over the problem. And then we use two for loops. One for loop runs from 0 to n, and another for loop runs from I plus 1 to n. So this is going to cover all the pairs of rectangle that we come across. Then we store the largest area in this variable using the max function. So we check the current existing maximum value stored in the variable, and then we also make a function find max area, where we pass the bottom left, the top right, the bottom left and top right of both the vectors that we're going to consider. So bottom left I, top right I, bottom left j, and top right j. So in this function find max area, we receive all the parameters that we have passed, and now we find the width. How do we find the width? We find the width the same way that I told you. So we take the top right corners of both the rectangle that we have been given. In the x direction, we take minimum of it to find the rightmost edge of the intersection, and we subtract maximum of bottom left and the bottom left of I1 as well as the bottom left of the second in the x direction. So we are able to find the left edge in the x direction. Subtracting subtracting the max from the minimum, we are able to find the width, and then we do the same for the height as well. But in this scenario, we do that in the y direction. So once width and height we have found, we check that, hey, is the width less than 0 or the height is less than 0? If any of that condition satisfies, it means that if the width is less than 0 or the height is less than 0, it means that there was no intersection between these two pair of rectangles, and we simply return 0 for this scenario. For this case, for these two vectors for which we run our function find max area, because the intersection is not possible, so it's not possible to form a square as well. And then we find the side of the square that could fit inside the rectangle. So we find that using the minimum of either width and height, and we finally return the area of that square. So it's length to length into 1 LL for like typecasting into long. And we finally return the solution, and if it is the greater than the largest area that we have previously stored, it again gets stored in largest area, and after like going through all these two loops, then we finally return the largest area as the solution. So that's it. That was the solution. And the time complexity, as I told you, was like big O of n square, and the space complexity is O of 1. And yeah, this was all about this problem. I hope you were able to understand. If you have some remarks or suggestions, please do leave them in the comments, and do like the video if you are able to understand it, and subscribe the channel for more such videos. I hope you have a great day ahead. Bye and take care, everyone.